You pick up two USB-C chargers. They look identical, same port, same cable shape, same USB-C label. Yet one charges your phone in 30 minutes, the other takes 2 hours. How is that possible? Why can one tiny charger deliver 20 watts while another delivers 65, 100, or even 140 watts, all through the exact same connector? Is it the charger, the cable, the phone, or some invisible negotiation happening the moment you plug in? What if I told you that every time you connect a USB-C cable, your devices are having a rapid digital conversation about voltage, current, safety limits, and power profiles? And the slowest link in that chain decides your real charging speed. Stay with me, because the reason USB-C chargers look the same but perform so differently is one of the most clever and confusing engineering systems ever put into everyday gadgets. Welcome to Story Behind the Things. Let's start with the connector itself. USB-C was designed as a universal reversible plug. One physical shape for phones, laptops, tablets, headphones, and more. That physical uniformity is exactly why people expect the performance to be uniform too. But the connector is only the doorway. What actually flows through that doorway is controlled by a smart protocol called USB Power Delivery, USB PD. Older USB charging was simple and limited, mostly 5 volts at low current. Then devices started needing more power, phones wanted faster charging, laptops wanted to run and charge from one cable. So the industry created USB Power Delivery. Here's the key idea: when you plug in, the charger and the device don't just start dumping power, they negotiate. The charger advertises what power profiles it can safely offer, for example 5V, 9V, 15V, 20V at different currents. The device looks at that list and requests the highest combination it can safely accept. The cable also plays a role, especially for higher power. That's why two chargers that look identical can behave so differently. One may only support basic PD profiles up to 18 watts or 30 watts. Another supports full PD 3 or 3.1 with higher voltages and currents, reaching 65 watts, 100 watts or more. There's an even smarter layer called Programmable Power Supply, PPS. Instead of jumping between fixed voltage steps, PPS lets the voltage change in tiny increments as small as 20 millivolts. This allows the charger to stay closer to the battery's actual needs, generating less heat and often charging faster and more efficiently, especially on many Android phones. For very high power above 100 watts up to 240 watts, there's Extended Power Range (EPR) introduced in USB PD 3.1. That requires special cables and chargers rated for higher voltages, 28 volts, 36 volts, 48 volts. And then there's the cable itself. Many USB-C cables look the same but are not. Higher power cables, especially those rated above 60 watts, contain a tiny chip called an E-marker. This chip tells the system, I can safely handle 5 amps, or I am rated for 100 watts/240 watts. Without that chip, the system often falls back to a safer 60 watts maximum, even if your charger and phone are capable of more. So the real speed is determined by the weakest link in the chain. The charger's supported power profiles. The device's maximum accepted power and protocols, PD, PPS, etc. The cable's rating and whether it has an E-marker. Even the quality of the internal components. Interesting facts most people don't know. A basic USB-C port without power delivery tops out at 15 watts. USB PD 3.1 can deliver up to 240 W, enough for high-performance laptops. PPS, Programmable Power Supply, adjusts voltage in tiny 20 millivolt steps for cooler, more efficient charging. Many 100 watts cables only work at full power if they contain an E-marker chip. The cable, charger and device all have to agree, the slowest one sets the real speed. Apple devices generally use USB PD, but do not support the PPS protocol that many Android phones prefer for peak speeds. That's the story behind why USB-C chargers look identical but charge at such different speeds. A sophisticated digital handshake happening in milliseconds every time you plug in. If you enjoyed this deep dive, make sure you're subscribed to Story Behind the Things. Drop a comment and tell me, what's the most surprising charging speed difference you've experienced? Or what other everyday tech mystery should we tackle next? Your ideas are read, acknowledged, and often become future videos. And if you're ready for the next story, hit that next button. I'll see you there. Thanks for watching.